Okay, let's get started. So last time we were talking about how you could write an exponential function in different ways by looking at variations on the 1 unit growth factor. So we want to spend a lot more time on that. Okay, ready to start? So here's an example. This is from, what is this, worksheet 5? Tell me what page that's on. Page 149. Let's do this first one together. We'll talk about what's going on. Okay, are you ready to start? Feel like I'm talking over people. Ready to start? Feel like I'm talking over people. Ready to start? Yes. Thank you. Okay, page 149. So this is showing the bacteria population for a number of months. Okay, so the 1 month growth factor, this is an easy one, you can just see it, right? So we look at, so in order to see the growth factor, should we look at input or output or one of each? If we're trying to figure out what the growth factor is. What should we look at? Output values. The growth factor is the number multiplied by a certain output that gives you the next output, 1 unit away. So what's the multiplier for every number of months? What number do we multiply by to get the next output? Very easy, right? This just, boom, times 3. Boom, times 3. This is called the 1 month growth factor. So before we just called this the growth factor, but now we have different growth factors, so we're specifying which one it is. This is the one that we would call the growth factor because it corresponds to an input increase of what? 1. So that's the main growth factor when input increases by 1. So this is the growth factor. But in the context of looking at lots of growth factors, we call it the 1 month growth factor. So it's 3. So then what is the idea, say, of the 2 month growth factor? The idea behind it would be, it's still a multiplier because it's a growth factor, but now it's the multiplier for what? Every 2 months. To jump ahead 2 months. So it's what number do you multiply by to get the number of bacteria 2 months later? So is it 6? 4 times what is 36? 9. Okay, notice something. What 2 months is like going directly to 2 months is like multiplying by the 1 month, what? Twice. It's like 3 times 3. This advances us 1 month, and then this advances us a second month. Using exponential form, that is 3 squared. You see? So 3 squared is the 2 month growth factor because we multiply by 3 twice to get that 9.
So this kind of just, instead of putting in a fraction, like it's not 1 of 12 like we did last week, but it's now you're going to forward.
Right.
So it's a full something.
Yep. So what would let's instead of the 3 month factor, let's do the 5 month growth factor. So that would be the number multiplied by 4 that would give us what? He wants 972, is that right? Yep, it's the number that if you multiplied by 4 would give you 972. It's also the number if you multiplied by 36 would give you what? 8,748. Anytime you're at any output now, we're saying, what would the bacteria be 5 months later? That's the multiplier for 5 months. Okay, so there'd be different ways to write this multiplier. What's one way to calculate or write out what this 5-month growth factor would be? Just one way. Okay, he wants 3 to the 5th. Would it work? Yeah, because it's equivalent to advancing forward 3 months. Sorry, 5 months. Every time you advance forward a month, you multiply by 3. So if you advance forward 5 months, you're going to multiply by 3 5 times. 3 times 3 times 3, or sorry, 4 times 3 times 3 times 3 times 3 times 3. Or in other words, 4 times 3 to the 5th. Or 36 times 3 to the 5th should give you 8,748. What's another way? So if we had this number 4 and we had this number 972, what would be another way to represent the 5-month growth factor? Would be another way to represent that number.
972 divided by 4.
He wants 972 divided by 4. Would that give you the multiplier? Yeah. So that 3 to the 5th should be the same as 972 divided by 4. It's how many, so what this is relative size. It's how many times bigger 972 is than 4. Okay? Half-month growth. So does it make sense so far? Okay. Half-month growth factor. So what's the idea of a half-month growth factor? That if we multiplied 4 times the half-month growth factor, we would get, well, we don't know what we get. All right? But we can, so now we have to change. So at 0 we have 4. At a half, we don't know. And at 1 we have 12. Do we have the average of those two? Well, we have 8. 8 bacteria, the average. If there was 8, what kind of, if it was 4, 8, 12, what kind of growth would that be? What would that be? Linear, additive growth. But this is growing exponentially. So we don't want to put 8 there because that would be like constant rate of change. So there's something else besides 8 there. So let's think about it. Is it going to be a number less than 8 or greater than 8? Why less?
Because it's only 1.5. So only 6.
What stays the same when you go from here to here and here to here? Exponential growth is all about multiplying, and then but we said that there's something associated with that.
Previous number.
Percent increase, right? Isn't it always the same percent increase? So here we're going to be taking the same percent of a higher number to get to 12. So should that be less or more than 8? Less than 8. Yeah, less than 8, because when you take percent of a higher number, you're going to get a bigger jump. So we want a smaller jump and a bigger jump. So that would be, it's going to be less than 8. Okay, that was for free. You don't have to pay me for that. Okay, so the question is, then, what do you want to call this 1/2 month growth factor? We can call it something because we don't know what it is. Call it B. All right, so if I multiply 4 by B, I'm going to get how much I have at half a month. And then what? If I multiply it by B again, whatever that number is, I should get 12. So can you write an expression that brings together these values? Write an equation that brings together 4, B, and 12. This is making sense. B is the 1/2 month growth factor. Oh, it slipped. So this is time. This is our number of months. This is our bacteria. So, can you write an expression of numbers here that will help us solve for B?
4b squared equals 12.
He wants 4b squared equals 12. Agree with that? Start with 4, multiply by b, multiply by b again. We should be at 12. That's it. 4b squared equals 12. Okay, so b squared is going to be equal to 3, and b is going to be 3 to the, or the square root of 3. So this is the number that you're going to multiply 4 by to get how many bacteria, or the mass, I'm sorry, the mass a half a month later, and then again to get the mass a whole full month later. So let's just confirm that we said 4 times 3 to the 1/2 should be more or less than 8? Less than 8. Just confirm that. So how much is it? $6.9? 6.93? Okay. So then, what would the 1/4 month growth factor be?
So the growth factor then for that one is 3 and raised to the 1/2.
That's right. So every half a month, the multiplier to get the mass, the mass in the next half month will be you multiply by 3 to the 1/2. So what about the 1/4 month growth factor?
3 to the 1/4.
Yeah. So here's kind of the danger. It's good, but it's a danger as well. So yeah, it's 3 to the 1/4. But what you really want to understand is where that comes from. This process, the same process that we got 3 to the 1/2 from, it's crucial that you understand that and so yes, after we see the pattern, we can use the pattern and write the answer down, but the process is extremely important. So that process should be familiar. It's the same thing. What's the multiplier that's going to get us what we want?
So what if it like asked for 1.5 months? You can just add like what you get for 1 month growth factor to what you get after 1 month to get 1.5. Would it be like 3 halves?
Yeah, you do the same. You can do the same thing. So what you could do is you would from 0. What's 1.5 months? It'd be right here, right? So there'd be some unknown. There'd be some unknown amount at 1.5 months. So I'll write that in here. 1.5. So 4 times. Let's call it C now. All right. And then from there, if we multiplied that number by C, what should we get? How many bacteria should we get? If I multiply, so I'm going to take 4 times the 1.5 month growth factor to get this unknown amount. But then if I take that and multiply it by C, what should I get? 108. Because we're always advancing 1.5 months. So we do the same thing. 4C squared equals what? 108. You see? And what you said was true. You're going to get C. So C squared is going to be, this is going to be, well, yeah, 27.
Yeah.
And so then C is going to be the square root of 27, which is 3 to the 3/2.
Okay.
Yep.
All right, cool.
Be 3 to the 3/2. Okay, so now because we have all these different growth factors, there's lots of different ways we can set up the function to model this growth, and we'll all model it, but just with a different time frame. Okay, so the easy one is by month. So that's what they're asking for here. Determine the function, determine the number of bacteria, X months, since there were 4. So we'll call that one F. So what's our so first of all, what's our general form for an exponential function? A b to the x, okay? We're going to take a times, what does b to the x mean? What does b to the x mean? Take the growth factor and do what to it? Multiply it times x?
X number of times.
X number of times together, right? If we want it on the third day, then it's going to be 3 b's multiplied together because we're advancing 3 days. So we need a b and a b and a b, okay? So for this, what is our initial amount? A is what? 4. Okay, always 0. Okay, so it can be confusing. Sometimes you might think you might use A corresponding to 1, but it never does. The initial value always corresponds to the input of 0. That's right. What's B? This is if we want to know how much we have after X months, then we need the 1 month growth factor. Okay, but we need to set up some other ones here. That's kind of the review, kind of easy. Okay, so what if t, here's kind of a, all right, so g, so g of, say, y. And let's let y be the number of 5-month periods. Y is the number of 5-month periods. Okay? So what's the initial value? 4. So what we're saying is, what is the growth factor for every 5-month period? 5. Is it 5? Every 5 months. What do we multiply to get this number, the next new number of bacteria? Was that what this was? 3 to the 5th. So you could put 243 in there, you could put 972 over 4, whatever that is. But every time we multiply by a 5-month period, or sorry, every time we advance a 5-month period, meaning we make y 1 bigger, we need to multiply by 3 to the 5th, right?
Can you write 3 to the 5y?
Yep, and you can write 3 to the 5y, absolutely.
3 to the 5 raised to the y?
And so this kind of shows it. I think this is the most helpful way to see it. Because every 5 months, that's why, every 5 months, how much does the bacteria grow? We know it grows. It grows by 5 3's multiplied together. Okay, so what I want you to do is let t be the number of years. If t is the number of years, I want you to write this growth in terms of a function of t. So h of t. H of t is the same bacteria where t is the number of years. Can you do it? H of t. Initial amount? So here's the thing. We want to, as t advances, every time t advances by 1, how many months go by?
12.
12 months. So in 12 months, what would the multiplier be to get the new number of bacteria?
3 to the 12.
What was that? They're saying, 2 of them have said 3 to the 12th. Agree? That's it, 3 to the 12th. Because 3 to the 12th is what growth factor? Yeah, the 1 year or the 12-month growth factor is 3 to the 12th.
And then the T is just the number of years.
Right, so if t were 4, right? If t were 4, that would mean, or sorry, t were 5. So let's say if t were 5, we'd have the initial amount of bacteria, and then we'd have to we'd end up multiplying by how many 3s?
60.
Yeah, it would look like this. H of 5. We'd have 4. 5 years would be the same as 60 months. And so we need to multiply 3 for every month. And so this number of years, so this is, we want to keep it 3 to the 12th. It's a really big number, okay? But that's a really, really large number, in the millions or billions maybe, or trillions. And so every year, that's the multiplier for the number of bacteria that we get 1 year later. Okay, does it make sense? So let's talk about percent change now with all this stuff. Percent change. What's the 1 month percent change? Think before you speak. What's the 1 month percent change? So I'm gonna erase all this. Instead of growth factors, I'm gonna put percent changes in here. Can I erase everything? Okay, so now let's talk about percent change on all these. What's the 1 month percent change, or how would you find it? Remember, it was easy when we had stuff like 1.05. What's the percent change? 5%, because it was 1 plus 0.05. So do the same thing.
It's 200%.
He wants 200%. It's 1 plus what? 2. So we keep what we had before, and what's the percent increase? 200% increase. So my question is the 2 month percent increase, is it 400%? Yes or no? More or less than 400%? More, because we're going to now take, we're going to increase by 200%, but we're increasing a bigger number by 200%. Do you see? So what was our 2 month growth factor? 9, which is 1 plus 8. So this is 3 squared. Was our 2 month growth factor equals 1 plus 8, which is, wow, not even close to 400%. You see this? So here's the moral of the story. To get percent increase, what do you base it off of? Other percent increases? No, you base it off of growth factor. Growth factor is always the centerpiece of these things, whether you're talking about percent change or forming the function or just understanding what's going on. It's always about the growth factor. You can't take one growth factor and assume what another one is. You can't take 1% change and just do a multiply to get the other percent change. You've got to find the growth factor that you want. Okay? So how about the 1/2 month percent change? You find that. Find the 1/2 month percent change. Go. What would the 1/2 month percent change be? Is it going to be 100%?
No.
Right. You can't just take half of 200% to get that 1 month growth factor. Right? Percent change. You're going to have to use the growth factor. So we can rewrite it as 1 plus what?
1 plus 5.
What is 3 to the 1/2?
1.732.
Let's see, that one's easy to see, right? 1.732? Easy to see percent change. How much? Again, notice it's not 1/2 of the 1 month percent change, 200. So growth factors remain the centerpiece. If you want a percent change of a particular amount of time, you need the growth factor for that particular amount of time, and you can find the percent increase. Okay, the rest of class is to finish this worksheet, and I'm going to call you down for a previous check of your notebook. So, lots of practice on this important worksheet. Lots of practice on the different growth factors. Two is more challenging. Go slow. Make sure you get it. No, the whole worksheet. Yep. Sure.
So I just want to know how much to do on that worksheet. How far do you go?
Definitely went through this, and then we at the very end we worked on number 3. So we got through most of everything through 3.
Okay. Is that what you're checking?
No, you're good.
Is that what you say?
Okay, last names A through E. Let's line up on this side. A through E. Okay. Thank you. Last name? Last name? Gotcha. Mike, right? Four. Yeah. Okay. Very good. What's your last name? Olivia? Okay, gotcha. Okay. What's your last name? Tanner? Last name? What is it? There. Jacob? Okay. Any more A through E? Any more A through E? C through G. C through G. Okay, number 2. So let me leave it up to you. We don't have time to talk through the whole rest of the worksheet, so I'll take by request here. Two, 3, or 4? 2. Okay. So the first thing is 2-day decay factor. Notice how the table is set up. Did you notice how the table was set up? What's different about this table? What's the jump in days? 2. So it's actually set up for you to find the 2-day decay factor. How would we set that up? So we don't have a calculator. We want to represent that 2-day decay factor without a calculator. How would we get the multiplier that multiplied by this 70 number would give us this 28 number?
28.125 over 70.
He's suggesting the 28 divided by the 70 number. Will that give the multiplier? People are saying yes. So 28.125 over 70.3125. And what do we get? 0.4? That's kind of convenient. Okay, 0.4. So if the 2-day decay factor is 0.4, how can we quickly get the 6-day decay factor? How many? Go ahead. Okay, that would work for sure. We could do, she wants to do 4.5 divided by 70.3125. Will that get it? Definitely. What's another way to get this? How does 6 days compare to 2 days? How many 2 days? How many 2 days are in 6 days? 3. So that would mean?
0.4 for each day.
Yeah, so 1 times 0.4, another times 0.4, and then another times 0.4 would get us 6 days. So it'd be 0.4 to the third. If every 2 days we multiply by 0.04, then in 6 days we're going to multiply by 0.04 3 times. 1 day decay factor. So if you need to set up the table, you could set up the table. You could go 1, 2, and 3, and then this is our 70 number. Dot 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 dot. And then we don't know that one. And then this is our 28. If you need to do that, that's fine. And then we'd have the multiplier. What times 70 would give us that, something unknown, and then times again to give us 28. So how can we relate that to 0.04?
70 times 0.4.
Call it B.
Oh, so 70 times B.
70.3125. How many times would you have to multiply by the 1 day decay factor to get the amount 2 days later?
B squared
You have to multiply by 2 of them, right?
equals 20.
Okay, setting up these equations is a huge part of understanding what's going on. If you can set those equations up, you really understand what's going on. Because it's all about how growth factors work. How growth factors work. This growth factor B, we need to multiply 2 of them times 70.1325 to get 2 days later, because we said B was the 1 day growth factor. What's a way to get it from this one? So that we could solve that out and we'd get the value of B. But we can also get it just directly from the 2 day growth factor. Is it 0.04 divided by 2? What is it?
Raised to the 1/2.
Raised to the 1/2, and that's what we'll get. If we solve for B here, we'll end up with 0.4 to the 1/2. Okay, 1 hour decay factor, 0.4
Raised to the 1/2.
to the, divided by 24,
No. That's the 2 days.
raised to the 1/24.
Wouldn't that be? That doesn't work because it's a 2-day decay factor.
Oh, good call. So, what do we need to raise to the 1/24th?
0.4 to the 1/2.
Nice, very good. I was just testing you. 0.4 to the 1/2 is the 1 day, raised to the 1/24th. And then you could also say that's the same as 0.4 to the 1/48th. Because if we multiplied that together 48 times, that would be equivalent to what?
2 days.
2 days. So multiplying that number together 48 times is equivalent to 2 days. And that raising that to the 48th gives us 0.4, the 2 day growth factor. Okay, how can we find, so here's the information that we have. How can we find the initial amount?
With the 1-day growth factor.
And use the 1 day growth factor on what?
So it's A times 0.4 raised to the 1/2 equals 70.3125.
What do you think of this? This is what he's saying. We don't know the initial amount, but if we advance 1 day, that's our 1 day growth factor, we should get the amount after 1 day. What does A turn out to be?
111.17.
That's what I heard. Is that right?
38.
111.17? So, if we want it in terms of days, we want, if n is the number of days, our initial amount is 111.17. Is that what you said, brother? If it's number of days, then we're going to have n out here, and we're going to have the 1 day growth factor. What is it? Any questions? Okay, homework is due Wednesday. Did I cover what you wanted me to cover? Yeah. I just heard you say at the beginning of class. Yeah. Okay, let me turn this off.